We are from Group 44 to present our Data Communication and Network project. And here is our 6 members, and I'm Michelle Lominja with student ID 22008071. And for this project, we are talking about 5 protocols, which are HTTP, DNS, Telnet and SSH, FTP and TFTP, and last one, DHCP. So we are using ASP and Wireshark to display the performance of these 5 protocols. The ASP is the Enterprise Network, short form of Enterprise Network Simulation Platform, a network simulation software developed by Huawei, designed for network engineers to design, configure, and troubleshoot network devices in virtual environment. Whereas Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analyzing software, and protocol development and education. It captures network packets and displays them in details for analyzing. Wireshark is widely used by network administrators, security professionals, and developers to monitor and analyze network traffic, troubleshoot network issues, and ensure the security and performance of networks. And that's all for me. I'm passing to next presenters.
Hi, I'm Jonas, and I'm going to be talking about the HTTP. So basically, HTTP is a protocol that allows the data to be sent across the internet. This allows the user to visit the other websites hosted on the internet. So some HTTP concepts are the requests. So basically, this is a method. It contains a method, the URL, and the HTTP version. So and also the header is included in the middle. And secondly is the response. So it has the HTTP version, status code, and the reason phrase. And the middle of the HTTP response contains the metadata about the response. So this is the ENSP configuration. So as you can see, we have one client, one server, and 2 routers. And this is the configuration for router 1. As you can see, we have an IP address of 192.168.1 and 254 assigned onto Gigabit Ethernet 000. And also, we have IP address 192.168.23.2 assigned onto Gigabit Ethernet 001. And also, we route static both of these together. And for this is the IP interface brief. So as you can see, we managed to successfully assign both of these IP addresses onto the Gigabit Ethernets. And this is the routing table. So as you can see, we have 2 destinations and 2 routes. And this is the R2 configuration. So we assign IP address 192.168.23.3 onto Gigabit Ethernet 000, and we assign Gigabit Ethernet 001 onto IP address 192.168.23.2, and we route static port for these together. And as you can see, we managed to successfully connect both of these Gigabit Ethernets together. And this is the routing table for R2. And so for the server configuration, this is how we do it. We assign local address with 192.168.2.1 and the gateway 192.168.2.54. And for the client configuration, we put 192.168.1 and 1.2 and 192.168.1.2. And this is the end result. So basically, this is the result of a file from a transfer from the server all the way to the client.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Anul Mardia Kamal Arifin. My ID is 2200557, and I will be talking about DNS server domain name system. Yeah. So first thing first, I will be from my part, I will be talking about the DNS, right? So first thing first, I will have to create a network topology, in which, as you can see in the video up above, so I opened the ENSP and create a network topology, including which is at least you should have at least one router, one switch, and one PC. But in my case, I will be using 4 PC. Yeah, so connect these devices appropriately, and I'm using Ethernet cable, and then configure the router. So access the router's CLI or like command prompt and configure basic settings like the hostname, IP addresses, and routine. So in this case, I use the IP address is 192.168.1.1, and my subnet mask is 255.255.255.0. Then I create it, and then so you should, on the router, configure each of the DNS server, okay? So access the DNS configuration and access the DNS server settings, okay? And I am using 4 records, which is A record, quadruple A records, CNAME records, and MX records. So configure all of these in the router, and then close it. You know what I mean? Not like X, but like close it. But like close that tiny box, and then open each PC and put the DNS1 as the 192.168.1.1 each of the PC. Yeah, we have 4 PC, right? So each one of it, set it up to 192.168.1.1. Okay. Now we'll be verifying our server using the NS lookup. So open your command prompt on your laptop, as in mine, as you can see, and then verify each. Okay, just type in NS lookup and the record name, and the results should show everything you should know, everything you should need to know, like that. So by analyzing the resolution process using NS lookup, it provides a simple way to query DNS records. It shows the server used for the query and the response from the server. So, and that's all from me. Thank you.
Assalamualaikum, my name is Nurul Syazwani Bintia. My ID is 22006104, and I'll be continuing about Telnet and SSH. So first of all, we need 2 routers, R1 and R2. Connect the router using Ethernet link, gigabit internet 000 on R1, 001 on R2. Start both device, then double click R1. Set the IP address for R1 to the specific IP address 1.1. Then set the subnet to 255.255.255.0. Then quit. Do the same type for R2. Just change the IP address to 1.2. Then back to R1 command. Enable the telnet and set up password authentication by typing user interface VTY 0.04. Enter authentication mode password. Enter set authentication password cheaper telnet password. Enter protocol inbound telnet. Enter, then quit. After that, open R1 CLI in the same command to test connection from R2 to R1. Type telnet 192.168.1.1. When prompt, enter the password telnet password. To capture the traffic, right click on R2, then click capture. Next, for SSH, set the IP address for both R1 and R2. The topology are the same like telnet. After setting up the IP address, generate RSA key pair by typing RSA local key pair create. Then create local user for SSH by typing AAA. Enter local user admin, password cheaper, SSH password. Enter, then local user admin service type SSH, then quit. After that, configure the VTY line for SSH by typing the user interface VTY04, authentication mode AAA, protocol inbound SSH, and quit. Then enable Telnet and SSH server. Do the same step for R2. After that, we're going to verify interface status on R1 and R2. Both interface should be in upstate. Then ping R2 to R1, R1 to R2. Test SSH connection by Telnet 192.168.1.1. Enter username and password when prompt. That's it.
Hi, my name is Valerie. I'm going to be presenting about the Files Transfer Protocol (FTP) and Trivial Files Transfer Protocol (FTP). For the use case of FTP, it can transfer large files, manage websites, backup data over the internet, and as of for TFTP, it can bootstrap network devices and transfer small configurations files. And for the security of FTP, it can support for secure file transfer, example for FTPS and SFTP, and it can robust and feature-rich protocol. And lastly, it is suitable for a wide range of applications. And as for TFTP, it emphasizes on speed and simplicity. It minimalistic protocol with reduced overhead, and it has no authentication or encryption mechanisms. And lastly, it is suitable for trusted closed networks. So this is the configuration for FTP. It has client, router, and for server. So to start the device, I have to add the interface into Giga Internet. So right here it shows us that the IP routing table for router 1, And right here it shows us the IP interface brief and the IP routing table for router 2. As we can see that the left image is the basic configuration information of the server 1, which stated with the local address and gateway, and for the right image is the server information, which is the FTP server. And right here we have the basic configuration of the client 1 for the left image, and here we have the local address, gateway, and the IPv4 address, and the times is 4. And for the right image, we have the log information. Right here we have the client information, FTP client. So as we can see that the remote address is the same as the IPv4 address, and the port is 21, username is Huawei, password is Huawei123, and for the remote files we have the files that we save in the folder that we chose.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Faiman bin Muhammad Yusuf, and today I want to present about DHCP protocol. So here I want to present about the setup I created. So first of all, we got here the router, which is to manage traffic between this network and by forwarding data packets to their intended IP address, and allowing multiple devices to use the same internet connection. And also we got here the LAN switch that are connected to the 4 devices, and have 2 different VLAN, which is VLAN 10 and 20. For VLAN 10, the IP address is 192.168.10.0, and the 20 is 192.168.20. And then let's move on to our LAN switch configuration. So here we have the LAN switch configuration, which is I name it as LAN underscore SW, and then I created two VLAN, which is 10 and 20. And then port configuration is port 1 and 2 are configured as access port and assigned to VLAN 10, and 2 also, port 1 and 2 to VLAN 10, and then port 3 and port 4 to VLAN 20. So here we got also the trunk port setup, which is port 24. On the switch is configured as a trunk port, and allowing traffic for both VLAN 10 and VLAN 20 to pass through. This trunk port connects to the router. Alright, let's move on to the router configuration. The device is I name it as the sysname RTR. So the sub interface are created for VLAN 10 and VLAN 20 on the router. VLAN 10 and VLAN 20 on the router. So the sub interface for VLAN 10 is assigned the IP address 192.168.10.1, and VLAN 20 is assigned the IP address 192.168.20.1. So DHCP enablement is enabled globally on the router, and DHCP configuration for sub interface. The router is configured to handle DHCP request for both VLAN 10 and VLAN 20 using its global DHCP setting. DHCP pool creation to DHCP pools are created. One for VLAN 10, providing IP address in the 192.168.10.0_24 network with 192.168.1.10.1 as the default gateway, and 88 as the DNS server. And one for VLAN 20 also providing IP address in the 192.168.20.24 network with 192.168.20.1 as the default gateway and 888.8.8.8 as the DNS server. So let's move on to our connected devices. There are 4 PCs connected to the switch, which is PC1, PC2, PC3 and PC4. So 2 PC are connected to VLAN 10, which is PC1 and PC2, providing and will receive IP address from the 192.168.10.0, and also 2 pieces are connected from LAN 20, which is PC3 and PC4, and will receive IP address from the 192.168.20.0_24 network. So here is the capturing data. Here we got the SCP discover, the SCP offer, and the SCP request, and the SCP acknowledge. So I think that's all from me. Thank you.